Yes, domain and range and outputs of functions. The section that we're in right now is just a little bit of everything, and we learn a little bit of functions in one way and then we talk about them in a different way. But domain and range never goes away. That is part of math for the rest of forever. Okay, we always talk about domain and range. Do you guys remember what variables go with domain and range? I'll tell you. Domain are x values, yep, and range are the y values. Okay, so domain lists all the possible x values, range lists all the possible y values. Now, if they give me a set of points, you know that these are xy, 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 right?
Yeah.
So if I'm looking for the domain equals...
Oh, it's just all the domains listed, right?
Yeah, I'm just going to write down all of the x's. So I've got, what, a -2.
3, 0, -2.
Do I want to write -2 twice?
No.
No. I mean, yes, technically you can circle it, but then when I ask you to list the range, are you going to circle those two?
Is that 5 over 2 or just 2?
So I've got a -2 and another -2, and then I have a 0, and I have a 3. Now my OCD had me just put those from least to greatest, but I think Alex would accept it in any direction.
Wait,
What was
so
your question? What was your question?
What's that thing right on the negative? What is that?
That is a French brace. It's like a parenthesis.
Okay,
So it's just, here is our list of numbers. That's all that is. Okay, it's our list of numbers. It groups them together as a set. Sometimes when we have parentheses, because we're wise in the ways of ordered pairs, we could think that maybe it was an ordered pair. All right, so our range, did that in blue, so let's see, our range is, so there's another one of those French braces.
If you didn't want to write -2 twice, then what do you do? Like, you don't have to write it at
You
all?
do not have to. Once it's listed, -2 is part of the domain. Done. I don't need to say that it's part of the domain again.
Okay.
Yeah, so even though it's listed twice, I only need to write it once. Range. So now I'm looking at the y values. So I have a -9, and I have a -5, and I have a 2, and I have a 3. Feel pretty good about that? So x's and y's. Yeah, not too bad.
Wait a minute.
I'm waiting.
So I'm trying to figure out how you did this. Did you just like, okay, so you put -5 or -9, -5 to like positives and then negatives?
So yeah, so why did I jump all over? I did. I put them in order from least to greatest.
Okay. Oh, okay.
Okay, so from least to greatest.
And the domain is the first one of each parentheses.
Yeah, domain is our x values. So in fact, I could go through here and I could say that this is an x, 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 right? And a y, 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 y. Okay, find f of -1. What I don't know is, have you guys seen this notation before? F of x. Okay, so it's in there. So this is telling me, when it has f of -1, that says, what it means is find y when x equals -1. That's what that means. Direct translation. Find y when x is -1. So I'm going to come over here. I'm going to look at -1. Wow, those are really tiny, aren't they? I'm going to assume these are counting by ones. 1, 2, 3. Unless you guys can see otherwise.
I can't see anything. It's like a little white blur.
Wow, that's hard. Is that a -1 right there? Yeah, that's a -1. And so then if I go up until I touch my function, don't I touch the function right there? Right? Don't I touch the curve right there?
Yeah.
So what's the y value right there?
-1.
It's up the axis, so it would be a positive 1.
Can you use the paper a little bit?
Oh, yep, thank you for letting me know.
Wait, if it's wait. We're trying to find positive and negative, like positive 1, negative 1.
This says when x is negative 1, here's negative 1 on the x-axis. Do you agree? I went up until I touched the curve, the function, and then I looked over to see what y value that coordinated with.
Okay, so it's
Which
negative
was-
1 and negative 1, or negative 1 and positive 1?
Negative 1 gives me positive 1.
Okay,
What if I asked you for negative 2? What would it be?
negative 2.
No, look, come over to negative 2. Right, negative 2 is right there. Go up to your function. There I touched the curve there.
Negative 4?
It would be 1, 2, I think it's a positive 3.
Yeah. Oh, I thought,
I
whenever you
see
said negative 2, I thought you were talking about like what, like the number, like to go up.
Gotcha. Okay, this one should be familiar. Complete the function table, and it tells me the values to plug in for x, right? Which I'm not sure why that doesn't have an equals sign right there. It should. Equals. So I'm just going to plug in negative 4. We're going to go times negative 5 plus 3. What do we get? 23. Now it says plug in 0. Negative 4 times 0 plus 3. 3. Plug in 1. Negative 4 times 1 plus 3. You guys are really fast at this. Negative 4 times 2 plus 3. And negative 4 times 4 plus 3. Negative? Yeah, good. Okay, so again, the section is a little bit of this and that. So far, so great, though.
Wait. Never mind, sorry.
Did you get it?
Yeah.
I haven't done all of it.
Right. I got it down. It's okay.
Okay. So here we are back at function notation. I've got f of x, and I have g of x, right? So this one tells me find f when x is negative 2. So am I going to use the f or am I going to use the g? I'm going to use, what does it tell me to use?
Oh.
Tells me to use f. So to find f of negative 2, what am I going to replace that x with? Right there, negative 2. So I've got, so f of negative 2 equals 2 times negative 2 cubed. That's a lot of 2's in a row right there. You can type this in your calculator and hit enter, or we can do order of operations ourselves. Negative 2 raised to the third power. Negative 2 times negative 2 times negative 2 is a negative 8. Times 2 is a negative 16. Plus 2 is a negative 14.
Wait, so how did you get that? So you did, what did you do?
To get 14 or to set it up?
To get 14.
Negative, I guess. So we did negative 2 raised to the third power, which is negative 8, times 2 is negative 16, plus 2 is negative 14. We just did order of operations.
Okay.
All right, now we need to do g of negative 3. It's a two-part problem, right? We're going to plug it in f, or are we going to plug it in g? G. We're going to replace that x right there. 2 times negative 3 minus 1. Negative 7?
Yep.
Okay. When we began, we did domain and range of points. The next one, we're going to be doing some domain and range from a graph. Okay. Sometimes these can be a little bit trickier depending on the function they give you. So if you get stuck on this on your homework, please let me know. Is this one just a list of points again?
No.
Isn't this just a list of points?
Yeah.
Visually, it's visually a list of points, right? So I'm going to look at this, and I'm going to go through. Will you guys help me find the ordered pair for each one of these? So I'm looking for the x and y. So what point is this? It is a Negative 3, negative 3?
Yeah.
How about this one?
Um,
How about this one?
4, negative 4, or negative 1. Why am I saying 4?
I don't know. And this one is a 0, 4?
Yeah.
Okay. Now that I have those written down, it's easier for me to list the domain and range, right? Because I don't have to count it every time now. So my domain, all my x values. So that would be, I'm just going to go in this direction. Yeah, negative 3, negative 1, 0, and 1. When we read from left to right, it was nice because my values were in order. Kind of like that. So what way should I read from my range to be in order? If I go from the bottom up, would I be going from least to greatest? All right, so that's what we're going to do. We've got a negative 3, negative 1, 1, 4. Love it. Okay, so that was this one. I took up too much room. Instead of points here, I have a piece of a function, right? I've got this little stretch right here. So sometimes, what are we doing? That one's fine. So sometimes I like to do a little trick of the imagination. I like to take this function and in my mind's eye I squish it onto the x-axis. Okay, because domain is x, right? So if I were to squish this onto the x-axis, what would the smallest number be? Squish it on the x-axis, what's that smallest number? Negative 2, what's the biggest number? All right, you guys learned interval notation yesterday, right? This is where we're going to start applying it. If that's an open dot, am I going to have a parenthesis or a bracket? It can't equal it, so it's a parenthesis. So actually, it's negative 2. And then we go to 4. And is it going to have a parenthesis or a bracket? Parenthesis because of that open dot, right? That's our domain.
If it's an open dot, then it's parentheses.
If it's a closed dot, it's a bracket.
Okay.
Yep. So now let's do our range. Okay, so when I was visualizing the domain, I squished it onto the x-axis, right? So if I'm going to visualize the range, can I squish it onto the y-axis? Yeah. So remember, we go from least to greatest. So I've got to start down here, don't I? All right, so my range, we just decided it's going to be a parenthesis because it's an open dot. Squished onto the y-axis, that's a 1, 2, 3, negative 4. And it goes all the way up to 3. Ask me, Lachlan.
I'm so confused.
On the range, is that what got us in trouble?
Wouldn't that be 3? Positive 3?
So we're squishing onto the y-axis, so we would be from here to here, right? If I were to squish that on the y-axis. Did that connect it for you, seeing it drawn that way? So we're from a negative 4 up to a 3.
Oh,
Yeah.
it's like on the x and the y.
Yep, so when we're doing the, here, I'll use a different color. When we're doing a domain, we squish it on the x-axis from here to here. And the range, squish it onto the y. Yep. Last thing, this looks like 2 pieces, the way it's illustrated there. And this is one last problem. So it says, use the vertical line test to determine if the graphs on the right are functions. Are they on the right? Isn't that on the left? That's definitely on the left, isn't it? Okay, so what happens, I'm going to use this as my vertical line. This way is vertical, right? Definitely not this way. This way is vertical. Now, if this is to be a function, and we're not good at this yet, we're going to get better. one x value cannot have more than one y value. Now that sounds really weird, but if we look at it visually, I'm going to start on this one. Do you see how there are two dots on top of each other right here? And actually also over here too? If there are ever 2 points that are on top of each other, it makes it so it's not a function. So this vertical line test is actually really handy because look at this graph right here. Do you see how that function crosses? Here, let me make that nice and straight on the camera. Do you see how that parabola crosses that vertical line, my ruler, twice? So that means there are 2 points that make this not a function. So you guys help me here. We already said not, right? Because of this guy and this guy. We say this one is not, either is one, right? So not. How about this one? Not. How about this one? Yes. And how about this one? Yeah.
So like more like nicer ones,
Not. Yes. Not. So we got a little bit of everything, quite a bit of a variety. So let me know where you need help.